Today we're going to talk about 3 different kinds of triangle similarity. So we're going to start off with our first triangle. I'm going to call that triangle ABC. Triangles are always named for their point names or vertex names, but order doesn't necessarily matter. I can call this triangle ABC, I can call it triangle BCA, I can call it triangle CAB. I can even go in the other direction and call it triangle CBA, BAC. Right? Order is not really important in a triangle name as long as I include all 3 vertex names. So I'm going to put in a similar triangle, right? I'm going to use a scale factor of 2. So I'm going to put in my original side lengths and my image side lengths. And we're going to say that angle A and angle D are congruent, so are angles B and E, and angles C and F are congruent. So all 3 sides are proportional. All 3 sides had a scale factor of 2 going from small to large. And all 3 angles are congruent, so I can say that these 2 triangles are similar, right? So now we want to write what's called a similarity statement. I'm going to say that triangle ABC is similar to, that's what this symbol is in the middle, triangle DEF. But like we talked about in class, it's really important that corresponding parts go in corresponding places on your similarity statement. Notice that A and D both come first, and they're congruent to each other. B and E are both in the middle, and they're congruent to each other. Those are corresponding angles. And so are C and F. So if I change the order of my first triangle name, I need to change the order of my second triangle name as well. C and F are corresponding, A and D are corresponding, and so are B and E. So just kind of keep in mind that order absolutely matters in your similarity statement. So now let's talk about the bare minimum amount of information it's going to take in order to say these triangles are similar. Because to be honest, checking all 3 sides and all 3 angles sometimes can really take a lot of work. So we want to cut out as much of that work as we can, right, to prove 2 triangles are similar. We're going to start off by remembering that there's 180 degrees inside every triangle. If I add up all 3 angle measures, I'm going to get 180 degrees. So let's say the measure of angle A is 110 degrees. The measure of angle C is 30 degrees. From just that much information, can I find the measure of angle B? Of course, right? Here I have, between A and C, I have 140 degrees, and I need 180. So what's going to be the measure of angle B? 40 degrees, right? That's all that it can be. So now let's take a look at the second triangle. If the measure of angle D is 110 degrees and the measure of angle F is 30 degrees, what can we say about angle E? Well, angle E has to be 40 degrees as well, right? So let's look. If A and D are congruent and C and F are congruent, is that enough information to show that angles B and E are also congruent? Well, yeah, right? Because if these are both 110 and these are both 30, that by default says that both of these angles have to be 40 degrees and hence are congruent. So what happens then is that based on what we already know about similar figures, right, these are similar, and remember what happens in similar figures with their angles? Angles are always congruent in similar figures, and to be honest, at least with triangles, that's enough information to say that they're similar triangles. But we just showed that if I know that 2 angles are congruent to each other, 2 sets of corresponding angles, then by default, the third also has to be congruent. That means that I only need two congruent corresponding angles to show that my triangles are similar. So our first theorem today is going to be called the angle-angle similarity theorem, because it only takes two pairs of congruent angles to show two triangles are congruent. We're going to shorten that name to AA for angle-angle. So in your notes, please make sure that you have this definition. The angle-angle similarity statement says if two angles of one triangle are congruent to two angles of another triangle, then the triangles must be similar. Pause the video if you need more time. Let's go back to our two triangles for a minute. I'm going to put in two pairs of corresponding sides, and if you take a look, going from small to large triangle, I have a scale factor of 2. So we can see that the two pairs of sides are proportional. But is that enough to say that the two triangles must be similar? Let's take a look. So here I've got two of the sides. These are the two sides that are labeled from the smaller triangle. Does that say anything about the third side? Well, to kind of put your mind at ease, this won't be a perfect demonstration, but if I have a side that's 3 units and a side that's 5 units, does that say that my third side has a guaranteed length? I don't think so, right? It can be really, really long. It can be really, really short, but there's no guarantee just given two sides that the third side is going to be any particular length, right? That means that knowing two side lengths does not guarantee that the third sides are going to be proportional. But what if we added in one of the angle measures? If I knew that the angle in between the side that's 3 and the side that's 5 units long was 110 degrees, does that mean that I can move those two sides around like I did before? Absolutely not, because that angle would have to be set, right? So having that angle in between ensures that the third side can only be one length. There's no varying now, right? Well, if this third side can only be one particular length, all of a sudden we can say that if two sides are proportional, that third side's proportional. But it took the angle in between. Pay really close attention to the fact that the angle is actually formed by those two sides, right? We call it the angle in between the two proportional sides. Well, this is actually called the side-angle-side similarity theorem. Notice the significance of the name. The angle is in between the two sides. We shorten that name to SAS. In your notes, make sure that you get this definition. The side-angle-side similarity statement says, if the measures of two sides of a triangle are proportional to the measures of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. Remember that included means that it's got to be the angle in between or formed by the two proportional sides. Pause the video so you'll have more time to write. Let's go for one more. If all three sides are proportional, or in other words, share the same scale factor, right? In these two triangles, I have a scale factor of 2 going from small to large. That's basically what similarity is, right? That I have two triangles exact same triangle, just different sizes, right? All three sides have to be proportional. That, by default, means that my two triangles are similar. And this is actually called the side-side-side similarity theorem. Shortened name, SSS. So the side-side-side similarity statement says if the measures of the corresponding sides of two triangles are proportional, the triangles are similar. Make sure to pause so you can get that in your notes. And finally, let's go through a couple examples. Here I've got two triangles. I have a couple of sides and an angle that are labeled. Let's first take a look at the corresponding sides. If I'm going from small to large triangle, that makes the large triangle my new shape and the smaller triangle my old shape. So if I take 15 and 6 that are corresponding sides, I'm going to do new over old. 15 over 6, that gives me a scale factor of 2.5. If I do the same thing with my other set of corresponding sides, 5 and 2, 5 over 2 gives me that same scale factor of 2.5. So I have two sides at least that I know are proportional. And from the marks on the triangle, it's telling me that angle M is congruent to angle K. Now, is that enough information to say that they're congruent? And if so, by what theorem? We have two sides and an angle, but is it the included angle? Is it the angle in between the two sides? Yes. So I can say that triangle MNP is similar to triangle KLJ by the side angle side theorem. I probably should say side angle side similarity statement, but today by SAS is going to be enough. Here's two more triangles. I have a pair of sides labeled and I have an angle that I know is congruent. This, however, is not enough information, right? I can't get any other information from those two triangles, and one angle in one side is not enough. I cannot say that these two triangles are similar. But what would happen if I added another angle? If H and X are congruent and angles O and Y are congruent, is that enough information? You bet, right? If I have two corresponding congruent angles, then I can say triangle HOP is similar to triangle XYZ by the angle-angle similarity statement. Now, knowing similar triangles actually allows us to find missing pieces of triangles, right? So if I know two triangles are similar, ABC is congruent to triangle EDC, then I can use that to my advantage. Let's say that we're asked to find X, which is just the distance between D and C. Well, I can use my knowledge of proportional sides to make that happen. If I take 4 over X, right? 4 is kind of this longer leg of my smaller triangle, and X is the base of my smaller triangle. What side in my bigger triangle is going to correspond with EC? Hopefully you can see that that's AC. And what's the distance, what's the length from A to C? Well, this little portion is 6 and this little portion down here is 4, so the whole side length is 10, right? And what side corresponds with X? That would be 8. So I'm going to set this up in a proportion 10 over 8. 4 and 10 are corresponding sides, and X and 8 are corresponding sides. There's a lot of different ways I could have set up that proportion. This is just one of those many ways. When I do cross products, I get 10x equals 32. And when I divide by 10, I get x equals 3.2. And I've done what the problem asked me to do. I think that's probably plenty for today. Make sure to bring any questions that you have to class. Don't forget your notes. Hope your day is awesome, and I'll see you next time.